Welcome to the Cloud Data Architecture series. Today is session one, and we'll talk about the starting point by building an architecture, which is the building blocks. So, whenever we want to start any new design or we are trying to build a new architecture or a data platform, we'll always start with the basic building blocks, and from there onwards, we'll start mapping these against the requirements and the technology stack. So, today's session is dedicated towards understanding what are the various building blocks. So when we talk about building any data platform, these what you see on the screen now, these are the basic building blocks. I'll categorize it at a very high level as sources, then the data transformation jobs, the data storage, the data consumption, and finally the common services. The first four are the most important. The common services as important as these, but these are still not the part of the core framework. Though in today's time, it has become as important as the core building blocks. So let's just go through these one by one and try to understand what these really are and what are the different varieties in them. Starting with sources, uh, for building any data platform, there would be some sources involved from where we have to ingest the data or the source systems that are going to send us the data. The different types of source systems, there can be a batch sources or real-time sources. Batch sources are the ones who are sending us the data, say at the end of the day, or maybe as micro batches. In the old traditional world where we used to build data platforms, right, well, or the traditional warehouses, most of the batches that times were end of the day processing. But nowadays, we get a lot of micro batches when it comes to batch workloads, and there are also real time, right? Within real time, also, it can be a actual real time, like a streaming use case, or there can be sources which are sending data. Maybe as streaming, but we don't really need it to be processed in real time. It can be done in near real time or with a latency of few minutes. So within real time also there is this variation. So please check on the requirements. Do you really need a to implement a streaming use case, or do you need something where you can have a latency of few minutes, making it a near real time system? Now, apart from these high-level categories, the sources will be sending us data, which is either in a structured form, or semi-structured form, or an unstructured form. Right? Structured data is like your CSVs and RDBMS, where there is a proper structure to your source systems. Semi-structure is they are not completely structured, like your JSON and XML files, where there can be some attributes which might be present in one of the records and they might not be present in some of the other records. And the third is the unstructured data, like the social media comments, Facebook comments, the tweets from Twitter. These are all unstructured data where, or it can be also images or videos, right? So these are the different kind of sources. Now, how to process this, how to ingest, how to transform, these we will see in our later sessions in this series. Today's lecture will only focus on what are the different building blocks and try to understand uh, these in details. Now, once we get the sources right, then we have to either transform it or we have to first store it, right? Again, it depends on whether you are using an ETL kind of a mechanism or ELT kind of a mechanism. Okay. So let's say we are getting the sources and we are going to transform the data first. So in transformations, there are different tools that we'll have to think about and select based on the requirements. It can be these transformations, right? This can be a big data kind of a processing where you need the Hadoop framework or you need something like a Spark framework to process the data. Or if it is not really a big data kind of a use case. Now in today's world, right, most of the use cases are big data use cases because you get higher volumes, a lot of variety, right, with high velocity as well. But in case these are not a big data use cases, you can go from with some of a simple ETL tools also. But select these from the modern data stack. Now again, what is a modern data stack and all? There is a different lecture series that I have already created. Maybe you can have a look at it. But transformation is the building block where you have to look at the various key considerations for your transformations, and accordingly you have to fit or choose the tools of your choice. Uh, it can be ETL, it can be ELT also. So if it is ELT, you can choose the some of the cloud data warehouses itself to perform the transformations after storing the data. And that brings us to, data storage. Now, data storage is something which has been there for a long time, right? Right from the late 90s or the early 2000s, it was all about warehouse where we were storing the data in the warehouses. Post 2010, we started building data lakes when Hadoop started coming into picture. And the current trend, right? Like you must have been hearing a lot about lake houses. Lake houses are the one which have the features of both warehouse and a data lake. We can get the cost efficiencies or cost optimizations of a data lake with cheaper storages and all. Uh, but at the same time, we get features like from the warehouse world, like the asset features or the performance that is required for any BI workloads. So these are the different types of storages which are used. I won't say different types of storages, but high-level categories of how you are going to store the data. It can be a warehouse, it can be data lake, it can be a lake house, or it can be a combination of a warehouse or in a data lake, right? Or in some of the cases, right, it might be a combination of all three, where someone has just started building lake house and they still have the existing warehouses and data lake. Most probably that is what is going to happen in future. You cannot really go away from your traditional warehouses or data lakes so easily. So you will have to think about what kind of storages you have to use. Now the final part would be the consumption part. Right now the sources, you understand what kind of sources you are getting, but the consumption is equally important for you to build the transformation and the storage part, right? Are you looking to build only a BI kind of a workload? If that is the case, you just need a warehouse. But if you need something like an AI ML, you'll need an data lake also, right? So consumption has these various different things like BI, AI, ML. How you want to access the data? Do you want to, use some APIs to access data from these systems, or it is just, interactive queries that you want to run on top of your storage system. Uh, Based on these, right, what kind of a workload and use cases you have, again, you will have to select the tools and the platforms for these. Now, while these are the core building blocks, the common services is also very, very critical. And again, as I said earlier, in today's times, this is what has gaining more popularity, or people have started understanding that we need to focus more on this, especially with the data lakes and the lakehouse world, right? So, what are these? Data ops, data governance, and data security. Data ops is how you're orchestrating all these pipelines, right? There will be hundreds of pipelines in huge enterprises. This might be thousands of pipelines, right? How you're going to orchestrate these, how you're going to monitor and do the logging for all these things. That is what the data operation system is going to define. Data governance, most critical piece again, because it tells you how you're going to manage your data, how you're going to access your data, how you're going to share data with others. If there is any sensitive data or PII, PHI data, how you are going to uh, store this data in encrypted forms, right? So all these things comes under governance. It's governance is a very big umbrella. A lot of things come into governance. Also, data quality can be considered as part of that, where you need to ensure that you have the right quality control, the right kind of data in your target system. Else, people are going to get some wrong reports and wrong insights, which is not going to help. And finally, data security, again, one of the most important pillars, especially if you're building something in cloud. Most of the people are worried about security, right? So this will talk about the various activities that you need to implement, or various controls that you need to have to ensuring that you're protecting your data at all levels, right? Wherever it is residing, and whether it is data in transit or data at rest, right? How someone is accessing it, how do you mask this data, whether you need an encryption or whether you need a tokenization, whether the tokenization needs to be done at the on-prem level itself, or you're okay to tokenize once the data is inside the cloud. So all these things would come into the data security layer. These are the high level building blocks for implementing any data platform. They'll interact with each other. In our subsequent sessions, right, we'll look at um, each of these portion maybe, or more of the design considerations to select the tools and the choices, and what can be the design principles to build these building blocks. But for today's session, we'll stop here. If you've liked this, you can also subscribe to my Substack newsletter where I weekly try to write about some of the new concepts, mainly for the folks who are new to the cloud and data world. Thank you guys and have a good day ahead.